if an object starts from an initial position -3 and moves in the positive x direction and stops at +2, what will be the distance? What will be the displacement? Now here we write xi, that's the initial position of x, and xf, that's the final position of x. Now dx is the displacement, is equal to xf minus xi. That's the final position of x minus the initial position of x. So dx is equal to xf is 2, +2, then minus open bracket xi is -3. So dx is equal to 2 plus 3. dx is equal to 5 units. That is the displacement. So therefore, displacement is equal to 5 units along x. Is going towards x. Now, so how can you find the distance? The distance is going to be the addition of the points covered from the starting point to the final point. So it started from -3 and ended at 2. Therefore, the distance is just going to be 3 plus 2, and that will be 5 kilometers. Now, this one is 5 units. Oh no, this one is 5 units. This one is 5 units along x. Why we are adding along x is because displacement is a vector quantity, while distance is a scalar quantity. Distance is just going to be 5 units, but displacement is going to be 5 units along x. If we are considering a motion along east, we will say 5 units or 5 kilometers due east, or 5 kilometers due south, or 5 kilometers due west, or 5 kilometers due north. So that's how we say it. Displacement is both magnitude and direction, while distance is just talking about the magnitude. Distance here, it will be 5 units, and displacement here is both 5 units along x direction. Now, let me show you another thing. Let us assume that from another journey from that 2 and ended on 0. In that case, this place will be my xf. Then the displacement for this new position is going to be xf minus xi. dx is equal to xf will be 0 minus open bracket -3. And this is going to be, dx is going to be 0 plus 4. dx is going to be 4 units, still along x. Therefore, displacement is equal to 4 units along x. Then the distance, how do we calculate the distance in this case? The distance is just going to be from here. You are going to count it. All the points that was covered throughout the journey is what you are going to calculate under your distance. So from -3 to -2, that's 1, 2, 3, 4, 5, 6, 7. That is going to give you 7 units. 7 units. 7 units. And if you want to do the calculation, you are going to add from here, from -3 to 2. You are not going to consider this minus, just add the numbers together. That will be 3 plus 2. Then from that 2 to 0, you are going to add plus 2 again, plus 0. So by the time you add all this together, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 0 is 7 units. So either you count it like this, 1, 2, 3, 4, 5, 6, 7, or you add all the points. You add all the points covered in the forward x direction and all the points covered in the backward x direction. By the time you put all these points together, you are going to get your distance. Let me show you another instance. Let's assume that from that 2, or let me extend this one to 3. This is 0. Let me extend it to 3. Now from that 3, it takes its journey back to -2. From here back to -2. This will be my new final position. dx in this case is going to be xf minus xi. ds is equal to xf is -2 minus open bracket -3. ds is equal to -2 plus 3. dx is equal to, this will be +1 unit along, is still along x. Why I put plus? This plus is also still indicating that the whole distance, the whole displacement is along x direction. So we have put, this is the magnitude and this is the direction. Therefore, you say your displacement is equal to 1 unit along x. Then how do we calculate the distance for this? You calculate it this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our distance is going to be 11 units. So essentially, distance is just the addition of all the points covered. The forward movement is 3 plus 3, while the backward movement is 3 plus 2. 3 plus 2. The forward one is, it started from 3 and ended at 3. And then backward one is, it started from 3 and ended at 2. So do not consider the negative signs that are in front of these numbers here. Just add everything together. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 2 is going to be 11 units. So as you can see, distance only tells us about the magnitude of the points covered, just the magnitude, but displacement will tell you the magnitude and the direction. So displacement is just telling us the net position of an object that is moving. An object that starts from rest and moves along any direction, displacement tells us how many kilometers it has moved in a particular direction, while distance just tells us how many distances, how many points or kilometers or miles or meters it has traveled or covered while moving from rest to a particular point. Let me give you another instance. Let us assume that we have -4 here, and this man, this individual, started from this -3, moves in the positive x direction and stopped at +3, and came backwards and stopped at -4. What will be our new displacement? What will be our new distance? Displacement, don't forget, is xf minus xi. Displacement is equal to xf is, this place will be my xf. xf is -4 minus open bracket xi is -3. So dx is equal to -4 plus 3. 3 is going to give us -1 units along negative x direction. Along negative x direction. It's going along negative x direction. So meaning that this was its initial position, and now this is the final position, meaning that it is one step behind the starting point. Say displacement is -1 unit along negative x direction. Negative x along negative x, or you can just say -1. You can leave it like that, or you can even write 1 unit along negative x. If you write it this way, you are still correct. Then distance, how do we calculate distance? Distance is going to be all the points covered. When you add everything together, you get your distance. It started from -3, it goes forward how many points? 1, 2, 3, 4, 5, 6. That's 6 plus 1, 2, 3, 4, 5, 6, 7. 7 When you add these two together, it's going to give you 13 units. So the distance from starting point of this individual is 13 units, while his displacement is 1 unit along negative x direction. An individual starts from rest and goes in the east direction 3 kilometers, and then from that point he traveled back 2 kilometers. Now in this case, what is the distance? What is the displacement? The displacement for this journey is going to be just 1 kilometers. 1 kilometers due east, or you can just write 1 kilometers east. How did I get that? You are going to say dx is equal to the forward motion is 3 kilometers, while the backward motion is 2 kilometers. So dx is going to be 1 kilometers. Now, because my final answer is positive, it means that it is still in the east direction. Now, what about the distance? The distance is going to be the forward motion. It took him 3 kilometers. That's 3 kilometers forward motion and 2 kilometers backward motion. My distance is now going to be 3 kilometers plus 2 kilometers. Distance, therefore, is going to be 5 kilometers. Suppose a man starts from rest and goes in this direction 4 kilometers and continued again 3 kilometers due east, and then decided to go 2 kilometers due south, and then return back 5 kilometers in the west direction. Now let us calculate the displacement and the distance for this whole journey. Now this is the new position. This is the new position. Okay, let me paint this. Now let us calculate the displacement. You are going to resolve this forward motion and backward motion. You are going to resolve it into a single line. Once you resolve it into a single line, you combine it with this, and then you make it into a triangle. By the time you make it into a triangle, then you'll be able to solve what you want to solve. So what do I mean? The forward motion to the east is 7 kilometers. That is 4 plus 3. That will give you 7 kilometers. While the backward motion opposite this direction is 5 kilometers. So our displacement for this is going to be 2 kilometers. Now let me show you, because I've started using x. The x is equal to, the forward motion is 4 kilometers plus 3 kilometers. Then the backward motion is minus 5 kilometers. I am putting minus because it's going in the opposite direction to this. So dx is equal to 4 plus 3 is 7. 7 minus 5 is going to give us 2 kilometers. Now, because this is positive answer, it will be east. That is going in the east direction. So I've resolved this one and these two. I've resolved it into one. So if I want to redraw now, I can just simply draw, because it's going towards east, I can just simply draw an arrow pointing towards east. This is the starting point. Then I will write 2 kilometers. Then this line that is going towards south, I will join it to it. This is south, 2 kilometers. Then the displacement will now be, the displacement of this whole journey is going to now be from here to here. And here I can put dx. So look at this now. This is already a triangle. So how do we solve this? You can solve this using Pythagoras theorem. Now this is my hypotenuse. How do you find hypotenuse in a right angle triangle? Your hypotenuse is going to be square root of 2 square root of 2 squared. That's this side squared, the adjacent side squared, and the opposite side squared. The x is going to be 2 squared will give us 4. Then 2 squared will also give us 4. The x is going to be root of 4 plus 4 is going to give us 8. root 8 kilometers. So that's our final displacement for that whole journey. Now the distance is going to be, I remember the diagram, the total distance, I can say here that the displacement is equal to root 8 kilometers due, this is 2. I want to show you the direction. It was like this, the x. Look at it. Remember, this was initial position, this was the final position. Now, since was the initial, this is the final, the displacement is going to be in this direction. Look at, let me show you the cardinal point. This is north, this is east, this is south, this is west. So if you put it at this particular point, then this displacement is going to be in the southeast direction. So here you come and say, now to calculate the distance, if it started from here 4 kilometers and then continue 3 kilometers due east, and it then went down 2 kilometers due south, then it came back in this direction 5 kilometers due west. This is the position and this is the final position. This is towards west. Distance in the first journey it covered 4, in the second journey it covered 3, in the third journey it covered 2, in the fourth journey it covered 5. Distance therefore is going to be 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 5 is going to give us 14 kilometers. So let me give you another instance. Let's assume that an object traveled 3 kilometers due east and then from that point traveled 4 kilometers due north. What is the displacement? What is the displacement and what is the distance? So how can you find the displacement in this case? The displacement in this case is going to be, since this is the starting position and here is the final position, this is not, join the starting position directly to the final position and this gives you a right angle triangle, and here write dx. So if I want to find displacement, is going to be, so displacement side squared, that's the hypotenuse side squared, is equal to 3 squared plus 4 squared. The displacement side squared is going to be 9 plus 16. Displacement side squared is 9 plus 16 will give 25. This is going to be root of 25 and this will be 5. 5 kilometers in what direction? Let us determine the direction. 5 kilometers in what direction? This is, if I draw north here and I draw east here, it is going to be in the northeast direction. 5 kilometers northeast. 5 kilometers northeast. Distance is going to be the addition of all the distances covered in the first and the second journey. In the first journey it covered 3 kilometers, in the second journey it covered 4 kilometers. Distance therefore is going to give us 7 kilometers. Suppose a man starts from rest and travels 2 kilometers towards east, continued again 1 kilometer, and then decide to go south by covering 3 kilometers, and then decide to go east by covering 1 kilometers. In this case, what is the displacement? What is the distance? And you will see, if I rearrange this, if I redraw, you will see what I mean. So this is the starting position, xi, that's the x initial. or east initial. You can actually use any letter. So this is for the first journey, 2 kilometers. This is for the second journey, 1 kilometer. Then I can take this one up. This one is the last journey. Last journey. So all of them, they are all in the east direction. Then from here, I can now bring this one to south. Remember, this one is 3 kilometers. So if I add all this together, this is the south. This is the final position. This is the initial position. This is the final position. If I add all this together, it's going to give me 2 plus 1 plus 1. That is 4 kilometers. Remember, this is my initial position. Then draw this one down, 3 kilometers. Then this is X final position. Then to find the displacement in this case, this is going to be dx. Displacement is going to be square root of 4 square plus 3 square. Dx is equal to 16 plus 9. Dx is equal to 25. Dx is equal to 5 kilometers. But in this case, since this is the initial position and this is the final position, and this is south, this is east, it means that the displacement from the starting point to the final point is going to be in the southeast direction. So what about the distance? The distance is going to be the journey from the total distance covered from the first or starting position or the starting point to the final position, which is going to just be 4 kilometers plus 3 kilometers. 4 kilometers plus 3 kilometers. Distance is now 7 kilometers. So that's how you can distinguish between distance and displacement, how you can calculate it. Average speed and average velocity. So what is average speed? Average speed is written like this, is equal to distance over time taken. That's total distance covered over total time taken. Speed is a scalar quantity. Because distance is a scalar quantity, speed will also be a scalar quantity. Now, in this place, velocity is equal to displacement over time taken. Displacement over time taken. Velocity is a vector quantity. So now, distance can be measured in kilometers. It can be measured in miles. It can also be measured in meter. And time can be measured in seconds, minutes, and hour. Therefore, so depending on the unit of distance and time that you are considering, then your speed is going to have kilometer per hour unit. That is, if kilometers and hour is combined, or miles per minute. That's if miles per minute is combined, or meters per second. That's if meters and second is combined. Displacement is measured in meters. Then time is measured in seconds. So the unit of velocity, or let me just write, the unit of velocity is actually meters. Now for short, you can write S, that's the average speed, is equal to distance over time. Then for short, d over t. Since it's velocity, just know that this place is talking about displacement. Here is the first question we want to consider. A cyclist travels 18 kilometers east, then 24 kilometers north, then 10 kilometers east, and finally 70 kilometers south in 2.5 hours. The question asks us to calculate the total distance traveled, the displacement, the average speed and the average velocity. So how do we approach this question? Now let me draw the description of the journey here. The first journey is 18 kilometers east. So this will be 18 kilometers. Then it goes 24 kilometers, that is 24 kilometers north. 24 kilometers north. From there, it took 10 kilometers east. So this is 10 kilometers east and 7 kilometers south. So it returns back 7 kilometers to the south. Here is our starting position. Here is our final position. So A asks us to calculate the total distance. Total distance is going to be 18 plus 24 plus 10 plus 7. 18 plus 24 plus 10 plus 7. Total distance is going to give us 59 kilometers. That's it. Now to calculate the displacement, you have to resolve 18 and 10 into a single journey because they are both traveling in the east direction. So you are going to combine this 18 and 10 together, and that will give you 28. So this is going to be 28 kilometers. Since they are both traveling in the east direction, you will add the two of them together, and that gives you 28 kilometers. Look at this. This is going towards north, and that is 24. But it returned back 7 kilometers. So you are going to subtract 24 from, you are going to subtract 7 from 24, and that gives you 17 kilometers. This will be our x initial and this will be our x final. The displacement from the initial position to the final position is going to be the x. The x therefore is going to be root of 28 squared plus 17 squared. Let us add 784 plus 289. This is going to give us 13, keep 1. 8 plus 8 is 16 plus 1, that's going to give us 17. This is 7 plus 2 is 9 plus 1, that's going to give us 10. The x is going to be root of 1073. If you find the square root of, we are going to get 32.75 kilometers. So here is our distance for the whole journey, 59 kilometers, and here is our displacement. And note, we are asked to calculate the magnitude of the displacement, just the magnitude. You can also determine the direction. You were not asked to determine the direction from the question, but you can also determine the direction. It's in the northeast direction. It's in the northeast direction. So that's how you can calculate the distance and the displacement for this particular question. So we can now solve C, average speed. So to find our average speed is equal to distance over time. Average speed is equal to the distance we got the other time was 59 kilometers over the total time from this place is 2.5 hours. They're going to give us 23.6 kilometers per hour. And D asks us to find the magnitude of the average velocity. Average velocity is equal to displacement over time. Average velocity is going to give us 32.75 kilometers over time, 2.5 hours, and 13.1 kilometers per hour. So this is your answer for the average speed, and this is your answer for the average velocity. A particle moves along a straight line. It travels 120 meters east in 15 seconds, 80 meters west in 10 seconds, 60 meters east in 5 seconds, and 40 meters west in 20 seconds. Determine the total distance, the total displacement, the average speed, and the average velocity. So let us first know how we can resolve the whole journey. it goes 120 meters towards east, and 80 meters, it returned back in the opposite direction, 80 meters. And then it took another one 60 meters east. From here, it took it back 60 meters. And then another one is 40 meters west. It returned back again 40 meters. So how do we solve our final displacement? You can know your final displacement. Okay, let me leave it like that. This first journey is at it spends 15 seconds. This one is at 10 seconds. This one is at 5 seconds. And this last one is 20 seconds. Now, how do we solve A? A says to calculate the distance. The total distance is going to be addition of all these journeys. 120 plus 80 plus 60 plus 40. 120 plus 80 plus 60 plus 40. And 300 meters. That's our total distance. The total displacement is going to be displacement dx is equal to, this is in the east direction, 120, minus this one is in the west. Then this one is another east, plus 60. Then this one is returning back to the west, minus 40. So if you do that, you are going to get 60 meters. That 60 meters, since our answer is positive answer, that means it's in the east direction. Then C, the average speed. Average speed is equal to distance over time. Distance here is 300. The time taken, the total time taken is 15 plus 10 is 25. 25 plus 5 is 30. 30 plus 20 is going to give us 50. By the time you divide this, it's going to give you 6 meters per second. Then D, the average velocity is displacement over time. Our total displacement here is 60, and our total time is 50. If you do that, you are going to get 1.2 meters per second. A runner completes 3 laps around a circular track of radius 35 meters in 4 minutes 12 seconds. Find the total distance, the displacement, the average speed, and average velocity. Now, we are going to draw the circular part. He said a runner completes 3 laps around a circular track. This is the circular track of radius 35 meters. So he's going to start from here, that is xi, and he's going to also end here, because he completes, he says he started from this, he runs around this circle the first time, runs around it the second time, runs around it the third time. So that is 3 laps together. Now, this is what we are going to do. To calculate the distance, the total distance, we are going to say the total distance is equal to, since it's a circular path, we are going to put the formula to calculate the circumference of a circle. We are going to use it, that is 2 pi r times, it runs around it 3 times, that is times 3. Therefore, we say distance is equal to 2 times 22 over 7 times 35. 35 is the radius, times 3. If you do that, you are going to get 659.82 meters. So that's how you can calculate your distance. B says we should calculate displacement. Since it started from this point and ended at this point, our displacement is going to be 0. You know, displacement is xi minus xf. Since it started and ended at the same spot, our displacement is going to be 0 meters. C, average speed. How do we calculate average speed? Average speed is equal to distance over time. Average speed is equal to 659.82 meters over the time given is 4 minutes 12 seconds. 4 minutes 12 seconds. But I want to convert this 4 minutes to seconds so that everything can be in seconds together. So how do I do that? I will say 4 minutes over 1 times 60 seconds over 1 minute. 1 will cancel 1. and then 4 will multiply 60. That will give us 240 seconds. We have 12 already. That will be plus 12 seconds. That is going to give us 252 seconds altogether. So if you convert 4 minutes, 12 seconds altogether to 12 seconds, you are going to get 252 seconds. So I'm going to come here and say is equal to 659.82 meters all over 252 seconds. 2.618 meters per displacement. D, your velocity is equal to displacement over time. Velocity is equal to 0 over time. You already know that your displacement is 0. The question here, the answer that we got in this place, over time, the time here is 252. If you do that, you are going to get 0 meters per. A car travels from town A to town B, a distance of 240 kilometers. It covers the first 80 kilometers at 40 kilometers per hour, the next 100 kilometers at 50 kilometers per hour, and the last 60 kilometers at 120 kilometers per hour. Calculate the overall average speed for the journey. So if the car goes from town A to town B, we represent it this way. The total distance of the whole journey is 240 kilometers. That's the total journey. But he divided the whole journey into 3 segments. And the first part of the journey is 80 kilometers at 40 kilometers per hour. That's the first part of the journey. The second part of the journey is 1000 kilometers at 50 kilometers per hour. This is 100 kilometers at 50 kilometers per hour. And the last part of the journey is 60 kilometers at 120 kilometers per hour. Now we are asked to calculate the overall average speed for the journey. So this is what we are going to do. Since speed is equal to distance over time, and for this first journey, our speed is okay, let me list out what we're given in the first journey. Speed is 40 kilometers per hour in the first journey, while D is equal to 80 kilometers. So we are left with time. How can we calculate time? We are going to say time is equal to distance over average speed. And time for this place is going to be 80 over 40, which is going to be 2 hours. That is for the first part of the journey. The second part of the journey, the average speed is 50 kilometers per hour. And the distance covered is 100 kilometers. The time is going to be distance over speed, and that is going to give us 100 over 50. Time is going to be 2 hours. Now let us check this one. The speed for this particular question is 120 kilometers per hour. Then the distance is 60 kilometers. Time is going to be distance over speed. Time is going to be 60 over 120. And this is going to be 0.5 hours. We are going to add all the time together because 2 hours, he spent 2 hours to cover 80 kilometers in the first journey. He spent 2 hours to cover 100 kilometers in the second journey, and 30 minutes to cover 60 kilometers in the third journey. So we are going to add all the time together and see what the total time will be. 2 plus 2 is 4. 4 plus 0.5 is 4.5 hours. So the total journey took him 4.5 from town A to town B. The question now asks us to find, say, calculate the average speed. Now, the average speed for all the total journey is equal to total distance covered over total time taken. Average speed is then equal to the total distance from town A to town B is 240. kilometers. And the total time from here is 4.5 hours. 53.3 kilometers per hour. Here is number 5, and I want you to try this. So you pause this video, write the question down, and see if you can get it. A student walks 3 kilometers north, then 4 kilometers east. This is east. Then 3 kilometers south, then 8 kilometers west in 2 hours. So all the journeys from north to east to south and to west, all the journey together took him 2 hours. So you can calculate your total distance, and this is your total time. A says you should find the displacement vector. B, the magnitude of the displacement. On C asks you to calculate the average velocity, and the last one asks you to calculate the average speed. So you can pause this video, write this question, and try if you can solve it. And anywhere you're having any difficulty, take the video back, rewatch again, and then come back to this question. You'll be able to solve it. Don't forget to like this video, subscribe, and to share it with some of your friends that you know will benefit from it. Thank you.